Good day, grade 12s. On the last video, we talked about organic molecules, and we said the organic molecules are compounds that contain a carbon atom. Then we talked about homologous series. Then on the homologous series, we said we have alkanes, alkenes, alkynes, haloalkanes, alcohols, ketone aldehydes, and carboxylic acids and esters. Then we talked about the functional groups. Then the functional groups sathi zezazisibonisayo uba lena yi-alkane, lena yi-ketone, lena yi-aldehyde. Then umzekelo that we had, in fact we wrote all of the functional groups. For example, I have this functional group for the ketone. For the ketone, I have this functional group. Okay, this is the functional group, which is also known as, its name as carbonyl group. Okay, this is the carbonyl group. So we talked about so I will just drop the link for the first video on the comment and on the description. Then we talked about hydrocarbons, that these ones must only have the carbon and hydrogen only. So there must be the carbon and hydrogen only, that is the hydrocarbon. So today we will start with molecular formula, structural formula, and the condensed formula. Then if the time is not against us, sithethe nge-isomers. Then we go to the type of haloalkanes and alcohols, that is the primary, secondary, and tertiary. Sibona njani uba this one is a primary, this one is the secondary, this one is a tertiary alcohol or haloalkane. Now let's start with these formulas. That is the molecular formula, the structural formula, and a condensed structural formula. How to draw these formulas? Okay, let's go to the structural formula. You must make sure that all the bond lines appear. That is, let's say you are given this compound. For example, this is methane. This is a methane, but is a structural formula of a methane. So this carbon has 4 bonds, is bonded to hydrogen and another. So the bonds must appear as lines. Okay, which means we have the hydrogen, hydrogen even here, hydrogen even here. So this is the structural formula of the methane. If, for example, they gave us this compound that is ethane, and they say draw a structural formula, make sure that the bonds appear. The carbon is bonded to a carbon, then each carbon must have 3 hydrogen atoms. So this is the structural formula, because all the bonds are represented by bond lines. Okay, so another example of a structural formula, then if we are given this one, okay, yeah, so we have this carbon with 3 hydrogen atoms, this carbon with 1, and also these alkyl groups. Then we also have this one with the 2 hydrogens and this one with the 3 hydrogens. So when we draw this one, is lining, that is this, and this. So we have 1, 2, 3, 4. So ezi zikwi-parent chain yethu. Then this one has 3 hydrogen atoms. This one. Then this one has 1 hydrogen, and there is also the branch here. There is also that carbon with 3 hydrogen atoms. Then this one has this 2 hydrogen atoms. Then lena yona ibe na how many? Ibe na 3. So basically this is the structural formula of this compound, right? Let me draw another one here. Let's look at this one. H2, H1, H1, H3. Then we have another H3. So since we have this H3 and this H3, which means this one is a branch. So the parent chain has 1, 2, 3, 1, 2, 3, and this one is number 4. Number 4. Okay. So this carbon has 3 hydrogen atoms. Inale hydrogen, ale hydrogen, ale hydrogen. Then this one has only 1 hydrogen atom. This one. 1 hydrogen atom and also the branch. So there is that side chain. Okay. There is that side chain. Then this one has only 1 hydrogen atom, but this one has 2 hydrogen atoms. Now we have to count the number of bonds. If we look at this carbon, we have this line 1, we have this line 2, we have this line 3. We need 1 line, which means there is a double bond here. There is a double bond. Then to make 4, even here we have 1, we have 2, 3, 4. So this one is now an alkene. Alkene. The homologous series for this one is alkene because there is this double bond between carbon atoms. Then all of these are alkanes because there is a single bond between carbon atoms. All of them are hydrocarbons because they only contain carbon and hydrogen. Okay. Then see a molecular formula. Oh, let's go to condensed structure. Then when we say the structural is condensed, azizuvela zonke i-bonds. Not all the bond lines will appear. Not all the bond lines will be represented. Let's look at this one. So this one is a structural formula because I see all the bond lines. All the bond lines. So this is a structural formula. So you can convert this one to a condensed structural formula. So on a condensed structural formula, uzotsho uthi lena i-carbon ino-hydrogen abangaphi. Lena i-carbon ino-hydrogen abangaphi. Nanko hydrogen. So the first carbon has 3 hydrogen atoms. Then the second has 2. Then the third has 3. 2, I mean, this one has 2. Then this one has 3 hydrogen atom. This one is a condensed structural formula. Structural. Iyasixelela qha uba okay, lena carbon ine-hydrogen ezinga, but ayizibonisi ii-bonds zonke. It can also be drawn like this one. For example, so H3, CH3, this bonds to this one with 2. This one with the 2 and that one with 3. This is also a condensed, but since you see the bond lines, 1 bond line, so this one is semi-condensed. This is condensed. That is 100% condensed. This one is semi because you can see some of the what? Of the bond lines. Okay. Then let's go to a molecular formula. Molecular formula. That's a formula. So, molecular formula yona izoba na 1 atom. Then utsho how many atoms? How many carbon atoms? You just write carbon. We have carbon and hydrogen here. How many carbon do we have here? 1, 2, 3, 4. So we have 4. No bonds at all. Then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. This is a molecular formula. Okay? This is the molecular formula. Now if we can look at this one, an OH here. Okay? So, land is over as a structural formula. I will convert it to a molecular formula. I will change it to a molecular formula. So I will just count how many carbon atoms. I have 3 carbon atoms here. How many hydrogen atoms? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 hydrogen atoms and also 1 oxygen atom. This is a molecular formula. Okay? This is a molecular formula. Let me draw another one. So I will draw 1, 2, 3. Okay? Then I have a double bond O here. I have OH. The homologous series for this compound is the carboxylic acid. Carboxylic acid. Okay? Then I have 1. Then O. Then I have O here. Then I have 1, 2. So this one is an ester. The functional group of this one tells us this compound is an ester. Now let's write the molecular formula of this one. How many carbon atoms do you see here? 1, 2, 3. There are 3 carbon atoms. Then how many hydrogens? 1, 2, 3, 4, 5, 6. So there are 6 hydrogen atoms. Then how many oxygen atoms? I have 1, 2. I have 2. Okay? Then if you can look at this one, this is an ester. This is a carboxylic acid. So I see 1, 2, 3. I see 3 carbon atoms. Then let's count hydrogen. 1, 2, 3, 4, 5, 6. I see 6. Then this one, how many oxygen? 1, 2. I have 2. This is the molecular formula now. This is a molecular formula, and this one is also the molecular formula. But this one is a structural formula, and this one is a structural formula. Now, if you can look at these compounds, they have different structural formulas. Different what? Structural formulas. If you can see it. This one has OH, this one has no OH. So, which means they have different structural formulas. Then we get the new concept, which is isomers. Okay? Then we see the isomers. Right? So, which means we have isomers now. A new concept. Isomers. Now, if you can look here, if you can name this compound, this is compound A, this is compound B. This compound has OH, this compound has no OH, but they have the same molecular formula, but the structural formula is not the same. Then we get the new concept, which is isomers. Isomers are defined as organic molecules. Organic molecules. With the same molecular formula. Molecular formula. As you can see there, but they have different structural formula. These are known as isomers. which means compound A and B are isomers. They have the same molecular formula but different structural formula. Okay. Now let's go to the type of isomer. Let me just make a few examples. So let me make an example of isomers. The first example is this one. That is this compound A and B. So this one, they have the same molecular formula, but the structural formula is not the same. How? See, this one has what? OH, but this one has just O. There is no OH, right? So they have different structural formula, but the molecular formula, as you can see, is the same. Let me draw some structures, then we write the molecular formula, then we compare. Now, if you can look at this one that I'm going to draw now, 1, 2, 3. I have this compound with 4 carbon atoms. This one with 4 carbon atoms. I have this compound with 4 carbon atoms. Right? So this compound has 4 carbon atoms. And it has OH, which means this compound, let's say this is compound C. This compound, since OH is an alcohol, so alcohol, right? Then I have this compound D. Compound D has 4 carbon atoms. 4 carbon atoms. But enye carbon atoms iphumele ecaleni. Since iphumele ecaleni leya, ithethe ukuthi lona we have another type of structure here. So this one has OH, is also what? An alcohol, right? But this alcohol has no carbon ephumele ecaleni, but this one has 1 carbon that is not on the straight chain. Okay, so since, as you can see, this one has no branch and this one has this branch. This one is branched, and this one is unbranched, which means the structure of this alcohol C is unbranched. The structure of this one is branched. Now, let's check the molecular formula. So this one has 4 carbon atoms. Let's count each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 hydrogen atoms in this one and 1 oxygen atom. Then coming to this one, we have 1, 2, 3, 4. There are 4 carbon atoms. Let's count each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 hydrogen atoms and what? And H. This is the molecular formula. So this compound A is unbranched, compound B is branched. They have the same molecular formula, but any branched, any unbranched, which means they have the same molecular formula but different structural formula. Therefore, C and D are isomers, right? C and D are isomers. We have 3 types of isomers. We have number 1, the chain isom. Chain isom. So these ones has the same molecular formula, same. Sorry for that. They have the same molecular formula. Same molecular formula, as you can see. But they have the different types. They have different types of chain. Different types of chain. Now, if you can look at this one, These compounds, sorry for that, what is happening? This one. This is OA alcohol, it has OH, and this one is alcohol, OH, but this one is a branched chain. This one is unbranched chain, this one is branched what? Chain. Lee chain eline branch, which means D and C are chain isomers. Okay. Another example of a chain isomer is 1, 2, 3, 4. So we have a branch here. We have a branch here. Hydrogen, 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 hydrogen. Oh, let's say this is a bromine, Br. So this compound E is an haloalkane, haloalkane, because I see a bromine, haloalkane, right? Is the haloalkane. So this one, 1, 2, 3, 4, 5. Hydrogen, hydrogen, hydrogen. Okay, sorry for that noise. Hydrogen, hydrogen, hydrogen. Oh, this one's supposed to be Br. Now, if you can look here, if you can look to this one has that chain, and this one has this chain. Okay, then we have here this one and this one, but here we have only this one. Now, if ungakujonga or red, it's not red or one branch, right? We have one branch here, but here we have two branches. Okay, we have two branches, which means the types of chain here is not the same, but the molecular formula 1, 2, 3, 4, 5C by 5 for carbon, OH 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 hydrogen atoms. Then we have what? A Br or 1. Let's come to this one. So carbons are up 1, 2, 3, 4, 5. There are 5 carbon atoms. The hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 what? Hydrogen atoms and Br. They have the same molecular formula, but the chain is not the same. This one is branched, has only one branch, and this one is more branched than this one. So this is the chain isomer, same molecular formula but different types of chain. Then we have another isomer, isomer number 2, the positional isomer. Positional isomer. So this one is defined as the isomers that have the same molecular formula. Molecular formula, but different positions of the functional group side chain side chain or substituent. Okay, they have the same molecular formula but different positions of the functional group. Now let's look at this compound and this one. 1, 2, 3, 4. Okay, this is an alcohol. As you can see, it's an alcohol, right? 1, 2, 3, 4. Nalena yi-alcohol. Nalena yi-alcohol. Now, if we can look at these alcohols, we have the functional group, which is this one. The functional group is in the first carbon. The functional group is in the first carbon. First, that is the position. But the functional group here is the second carbon, or is in the second carbon. So the position is not the same. This is position number 1. This is position number 2. This is position number 3. This is position number 4. This is 1. This is 2. This is 3. This is 4. So this compound is named as a butane. Butane 1 all. This is butane -2 all. The position of all, that is OH, is not the same. Therefore, this is a positional isomer. So another one is this one that I'm going to draw now. 1, 2, 3, 4, 5. Hydrogen, hydrogen, hydrogen. Then here we also have the side chain. The side chain there. The side chain. Okay. 1, 2, 3, 4, 5. The side chain is also here. That is the side chain. Positional isomer, they have the same molecular form but different position of the side chain. Let's count the number of carbon atoms here. 1, 2, 3, 4, 5, 6. There are 6 carbon atoms. Let's count hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 hydrogen atoms. Let's look at this one. 1, 2, 3, 4, 5, 6. There are 6 carbon atoms. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 hydrogen atoms. Same molecular formula. Okay? They have the same molecular formula. But let's check the position of the side chain. Look at this branch. Look at this branch. So this branch here is on position number 1, 2, 3, 4, 5. But here 1, 2, 3, 4, 5. So this is on number 3, which means if we name this compound will be a 3-methyl. Methyl 1, 2, 3, 4, 5. Pent means 5 pentane, right? And this one has 1, 2. It's a 2-methyl. methyl pentane. The only difference here is the position of methyl. Therefore, it's a positional isomer, right? This is the positional isomer. So the last isomer now will be the functional isomers. We have three types of isomers here. In grade 12, we have positional chain isomer and a functional isomers. They have the same molecular formula. All of them, they have the same molecular formula. But there's something different, but different functional groups. Oh, this one's very simple. Now, we have only two types of these ones. A ketone together with aldehyde. So if you are given a ketone, you will write aldehyde. If you are given an aldehyde, you will write a ketone as a functional isomer. Number two, we have another combination, that is the carboxylic acid. Xylic acids. Ihamba ne-esters ke. Carboxylic acid ihamba ne-esters. Okay? So carboxylic acid ihamba ne-esters. Alright. So when you have the ester, the carboxylic acid, you write an ester. When you have an ester, you write a what? A carboxylic acid. So these are functional isomers. Alright? Now if we can draw this one. If you have this one and 1, 2, 3, 4, so and this one, hydrogen, nalapha we have hydrogen. This is the structural formula, right? Then let's write the molecular formula. We have 4 carbon atoms, 4. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, and 8 hydrogen atoms. Let's look at this one. 1, 2, 3, 4 carbon atoms. Hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8. So they have the same molecular formula. Oxygen here, only 1. Then here we have only 1 oxygen. They have the same what? Molecular formula. Now let's look at the functional groups. Now if you can look here, this is the functional group of this compound. So this functional group has carbon, double bond O and H. So this one belongs to an aldehyde. This is an aldehyde. Now if you can look at this one, this is the functional group starting from here to here to here. There is a carbon double bond O, but there is no H here. Okay, that's the only difference. There is no H there in that double bond O. So this is a ketone. So these are functional isomers. Now let's look at this compound and write the isomer of it. 1, 2. This is a hydrogen. Then we have this OH. So this one is a carboxylic acid. Reason is that there is this OH, right? So To write the what? The functional isomer of this one, we'll write an ester. We need an what? Ester. We need an ester. Remember, the ester has the functional group like this one, OC. Okay? Now, sizogcwalisa apha to make an isomer. How many carbon atoms do we have here? 1, 2, 3. Which means we will just have another carbon here. Okay? Then how many hydrogen atoms? Let's count oxygen. 1, 2, 1, 2. Hydrogen 1, 2, 3, 4, 5, 6. So we must have 6 hydrogen atoms even here. So this is an ester. This is the functional isomer of the carboxylic acid. And a functional group. That is the functional group. There is no OH, there is a OH, which means the structural formula is not the same. Alright? The molecular formula is the same. So that is the functional isomers. So we're done with the isomers. So we have the chain isomers. The chain isomers umehluko is that enye chain has no branch, then elinye has at least one branch. Elinye chain has a branch, one branch, then elinye will have 2 branches. Okay, that is a chain isomer. There will be a side chains. Okay, enye has 1, enye has 0 side chains. Then we have a positional isomers. In the positional isomers, we have a position, enye is of position number 1, enye O2. There will be the difference in what? In the position of the functional group or of the side chain or of the substituent, right? Then we have functional isomers. On the functional isomers, we have number 1, we have ketone versus aldehyde. Then we have carboxylic acid versus an ester. So masibambeni apho. Don't forget to subscribe, share, like, comment, ask questions there. Thank you very much. I'll see you on the next video, the types of alcohols and the haloalkanes. We have a primary, we have a secondary and a tertiary alcohol. So we are going to look at those types of alcohols on the following video. Thank you. Bye.